In this video, we're going to look at Chapter 15, Section A, on directed line segment representation. Let's consider a bus that's traveling at exactly 100 kilometers an hour in an exactly southeast direction. We know that southeast is 45 degrees south of the east line and 45 degrees east of the south line. I can draw exactly 45 degrees in that direction using a protractor, and I can use a scaled arrow, a ruler, to draw a scaled arrow to represent the speed of the bus. In this case, we'll set a scale of 1 centimeter equals 50 kilometers an hour. Therefore, we know that we have to draw an arrow that is 2 centimeters. So if I take my ruler and I orient it at 45 degrees, let's make it a little bit more life-size. Then I can draw an arrow exactly in that direction and exactly the distance that I need it to go, which in this case is 2 centimeters. Okay, so here's my arrow, and to make the picture a little bit more clear, we can go ahead and get rid of the ruler. And the protractor, and now I have my 2-scale arrow that's pointing in the exact direction that I need it to go. And these quantities are known as vectors, and we'll define a vector in a little bit more detail in the next slide. A vector is a quantity that has both magnitude and direction. And in this video, we've been representing both the magnitude and the direction with a scaled arrow. Now, in a textbook, you'll often see vectors represented with letters in several different ways. For the following example, we could represent the vector with the labels of its ends and a little arrow over the top, like this. Or we could simply represent the vector with a single letter designation, like this. And often in textbooks, instead of drawing that arrow, which is useful for students doing homework, the textbook would simply use the single letter designation with a bold letter, in this case a bold lowercase a. The magnitude or length of the vector can be represented in several ways as well. And some accepted notation for that is something like this, or this, right? OA without the arrow on top, or the absolute value of the bolded A, or the absolute value of a lowercase a with an arrow over it. And this is how most students would represent arrows, or the magnitude of an arrow in their notes. So this vector emanates from point O and ends at point A, and you should be familiar with all the different notations for both representing the vector as a whole and representing just the magnitude of a vector. In this example, we're going to use a scaled diagram to sketch a vector representing a velocity of 15 meters per second to the west. Let's quickly review our coordinate system here. I have north, east, south, and west. We also need a scale here, so we'll say that 1 centimeter is equal to 10 meters per second. So to solve this problem, we need to draw an arrow that is 1.5 centimeters long, which would get me 15 meters per second. I can use my ruler to draw a scaled arrow that's 15 centimeters long. And I'm going to increase the ruler here just for visual sake. So here's our line that's exactly 1.5 centimeters, representing 15 meters per second to the west. Okay, in this example problem, we want to draw a scaled arrow that represents a vector of 40 meters per second on a bearing of 75 degrees. So again, I need a scale, and again we'll use 1 centimeter is equal to 10 meters per second. So in this case, I know that I need an arrow that is 4 centimeters long, which is going to get me 40 meters per second. But this time I need to draw it on a bearing of 75 degrees. And remember, bearings start at north and go clockwise. So again, we're switching back here. We've been going the other way, talking about angles in the unit circle. Now we need to start at north again and go clockwise when we're talking about bearings for 75 degrees. To draw an accurate scaled arrow, we can use our protractor, and we'll line that up right at the origin. And we can also use our ruler, which we're going to draw at 75 degrees, which is on our protractor is actually going to be 25, like so, and then we can draw our arrow. Here's my line that's exactly 4 centimeters long on a bearing of 75 degrees. And we can get the ruler and the protractor out of the way. And here's our scaled arrow.